Okay, in today's video, we're talking about computing life probability and service life. So this is in chapter 4, S on reliability. Section 4S2, quantifying reliability. And then we'll be going over example 4S3 from that chapter. And one thing we're talking a lot about in this chapter is normal distribution. So if you had a statistics class recently, you probably remember this. But for those who might not remember, I'm going to walk through it pretty slowly. So this example says the mean life of a certain ball bearing can be modeled using a normal distribution with a mean of 6 years and a standard deviation of 1 year. Determine each of the following. Okay, so that means that the life of this ball bearing can be plotted on a normal distribution, which is this bell curve. Okay, and the mean is 6 years, so wear out mean time is 6 years, and standard deviation is 1 year. Okay, so our mean right here is 6 years. So that means that half of these ball bearings will wear out before 6 years, and half will wear out after 6 years, with the greatest quantity being wearing out at the 6-year point. So first we're looking at the probability the ball bearing will wear out before 7 years of service. So if this is 6 years here, 7 years is the Z number over here. Okay? So to figure out, we have to figure out what Z is, the value of Z. I'm sorry, my cat is attacking my computer, so I'm going to move her. So the value of Z is calculated as T minus the mean wear out time divided by the standard deviation of wear out time. So we're calculating Z. This will be calculated as T, which is 7, because in part A, we're looking for 7 years of service, minus the mean wear out time, which is 6, divided by the standard deviation, which is 1. Okay, so 7 minus 6 divided by 1 is 1. So that gives us the Z value. But we need to know what the area under this curve is up until this Z point. So basically everything in blue on this chart, we need to know what that area is. To figure that out, you need to look at table B2 in the back of your book. So table B2 looks like this. So it gives you the area under a standard curve, a normal distribution, up until a Z point. Okay? So we're looking for Z of 1. So find Z, go down here, and 1.0. So that area is 0.8413. 0.8413. So that means that the area under this curve is 0.8413. That also means that 84.13% of these ball bearings will wear out before 7 years. And that is our answer for part A. Okay, so that's A. For B, so B says the probability that a ball bearing will wear out after 7 years of service. So we're basically trying to find the area of this green section here. So the area of the blue is 0.8413. So what is the area of the green? Well, 100% of these ball bearings will wear out. So we know the area under this complete curve is 1. So to find the area of the green part, we just have to take 1 minus 0.8413. So 1 minus 0.8413 is 0.1587. So we know 15.87% will wear out after 7 years. And that is the answer to part B. Okay, finally part C. So C says the service life that will provide a wear out probability of 10%. So this is saying at what number of years, at how many years will 10% of these bearings be worn out? Okay, I needed to grab another table from the book. So we're going to use table B1 in the back of the book for this. So back here, the service life that will provide a wear out probability of 10%. Okay, 10% is going to be way over here. So looking at table B1, we're looking for the area of the curve under here that equals 10%. So we're going to do this backwards. We're going to look for the area in here and then find what z value corresponds to that area. So I'm going to scan this whole table and find the number that's closest to 10%, and I find it right here. See this 0.1003? That's closest to 10%. So we look at that row, that's on this row, negative 1.2. 1.2, okay? But then you also have to look at the column. So its row is negative 1.2. Its column is this column here, which is 0.08. Okay? And I add those together. So my z value is negative 1.12. Sorry, I messed up. This is negative. There we go. That makes more sense. Our z value is negative 1.28. So negative 1.2 and then 8 for the column. So at a z value of negative 1.28, the area under the curve is 10%. So going back here, we know our z equals negative 1.28. So we have to figure out what our t is. Okay, so remember t minus the mean wear out time divided by the standard deviation equals z. So we know that negative 1.28 equals our t, which we're solving for, minus the mean wear out time, which is 6, divided by 1. And I just want this to be text so we can see that. Okay, so negative 1.28 equals t minus 6 divided by 1. So let's divide both sides by 1, and we come out with 1.28 equals t minus 6. Okay, and then we add 6 to both sides. This is t minus 6. We're going to add 6 to both sides, and we get t equals negative 1.28 plus 6. Okay, and that equals 1.28 plus 6 equals 4.72. So that tells us the service life that will provide a wear out probability of 10% is 4.72. So 4.72 years will provide a wear out probability of 10%. In other words, after 4.72 years, 10% of these ball bearings will be worn out. So that's working through example 4S3, the focus on talking about how normal distribution works and how to use tables B1 and B2 in the back of your book.